Yes, hello students. So in this video we are going to see the Thevenins theorem example. So this is the example that we are going to find out the Thevenins equivalent network. Now in this example, as we have discussed in the last video, that it consists of the dependent source. So dependent source is depending on Vx, right? So now this is this source is depending on voltage source Vx, that is VAB, that is your VTH. Now we know that when it has a dependent source, we cannot find RTH directly. So there are three steps. The steps are: first one is find VTH, second is find ISC, and third, by finding VTH and ISC, we can directly say RTH is VTH upon ISC. What is VTH? It's the open circuit voltage at VAB. ISC is the short circuit current at VAB, that will short circuit AB and find ISC. So let us see how to find this. So for first one VTH, we have to open circuit VAB and find AB and find the Thevenin voltage. So let us see this. Now when I say this is open circuit, that is your one second, let us see back the circuit. When this is open circuit, what happens here is this current is 0. The current here is 0, right? And Vx is open. So we can say this current is 0 and this is open. Just let us write down here. This is 0.1 Vx and this is 2 ohm, this is 3 ohm, 4 volts, and the Vx is nothing but VTH. So whatever value we get for Vx, that will be VTH. Now this current is 0, but this current is, we are calling it as I1. Now let us find Vx. So this I1, you can see when I apply the KCL in this I1 is nothing but 0.1 Vx in opposite direction. So I can write here is I1 is minus 0.1 Vx. What is I1? Minus, because I1 is going down and 0.1 Vx is going up. So I1 is minus 0.1 Vx, opposite direction. Now we can apply KVL in the loop. KVL in the first loop. So what is the KVL? 4 minus 2 I1. We are moving in clockwise direction. 4 minus 2 I1, right? And then the current here is 0, right? That will be 0 minus 3 into 0 minus Vx. Because this voltage is Vx, so Vx equals to 0. KVL says that the sum of voltages in a loop is 0. So outer loop we are applying the KVL. This is not first loop, we can say outer loop. Yeah. So now we can put the value of I1 here. This is equation number 1 and this is 2. Place the value of I1 in 2 from 1 into. So 4 minus 2 minus 0.1 Vx minus 3 minus Vx equals to 0, right? This becomes 4 minus 3 plus 0.2 Vx minus Vx equals to 0. So it is 4 minus 3 into 0. Sorry, this is 0. 3 into 0 is 0. So this becomes here 4. 4 equals to 0.8 Vx. This is 3 into 0. So this is 0 here, right? Now what is Vx from here is 4 upon 0.8. That is nothing but 5 volts. And we know that Vx is nothing but VTH. So we got VTH as 5 volts. So Vx is 5 volts, right? So we can say this is the first step, that we got as Vx is VTH is 5 volts. Now let us start with the short circuit current, that is second step. So let us find ISC. For ISC we have to short circuit. So let us draw the circuit again, and this circuit is different. So Vx now here will be different. Don't take Vx from the last circuit. This Vx will be different. So we are short circuiting this. This is Vx is 0 because we are short circuiting to find ISC. So this is 0.1 by 1 Vx, 3 ohm, and this is 4 volt. Now when Vx is 0, this also becomes 0, right? This is open circuit because it's a current source, and when current source is 0, it becomes open circuit. The circuit becomes like this. So when Vx is 0, the circuit becomes like this, right? So Vx is 0, we can say this current is nothing but Isc. This is 2 ohm, this is 3 ohm. This will be open circuit. Now can I find Isc by applying KVL? Apply KVL. 4 minus 5 Isc equals to 0. So what is Isc from here? Isc is 4 upon 5. That is 0.8 ampere. So Isc we are getting as 0.8 ampere. This is our second step. So it becomes easy because Vx is 0, it became open circuit. So we got second value as Isc is 0.8 ampere. Now what is third step? Third step is we have to get RTH, and third step is RTH equals to VTH upon Isc. So VTH value what we got? We got 5 volts. So 5 and Isc we got as 0.8. So it becomes here is 5 upon 0.8 is 6.25 ohms. Right? So this is our RTH. Now the fourth one, we'll draw the equivalent circuit, the last equivalent circuit, Thevenin's equivalent circuit. You can write here Thevenin's equivalent circuit. So it says that we have to first write VTH. What is the value of VTH we got? 5 volt. Then we have to write RTH. RTH we got as 6.2 ohms. And this is your AB. So this is nothing but the Thevenin's equivalent. So thank you. Any doubts? Please write in comments.